So acids. This is the third category of compounds we need to learn how to name. So what is an acid? Acids are molecular compounds that release hydrogen ions when dissolved in water. There are some other definitions, but that's the one we're going to work with right now. So acids, the ones we're going to see, are composed of hydrogen, which is generally written first in the formula, and then one or more nonmetals. Those are written after the hydrogen. So here's an example of an acid, HCl. So I want you to identify acids as things that start with H. So you look at it, it starts with H, it's an acid. What's one exception? Water. We don't name water as an acid. We just call it water. So HCl, this is a molecular compound. It's two nonmetals. We said two nonmetals was a molecular compound. It is a molecular compound. But when we dissolve it in water, it separates and creates ions, hydrogen ions and chloride ions. The AQ here in parentheses means aqueous. Aqueous stands for dissolved in water. So we're going to name HCl as an acid if it's dissolved in water, if it's aqueous. If it was a gas, we would give it a molecular compound name. What would this be as a molecular compound? Hydrogen chloride or hydrogen monochloride. Occasionally they drop the mono on the second one too. We're not going to worry about that. So there are some compounds that have hydrogen, but they don't dissolve in water, so those are not considered acids. And that's one of the reasons we don't consider water an acid, because does water dissolve in water? That's kind of a silly question. No, water is water. It's just water, it's not an acid. So acids have some characteristics. They taste sour. So anybody here like Sour Patch Kids? So that sugary stuff on the outside, I think there's some sugar in there too, but there's malic acid, which is it's a natural acid from grapes, but acids have that sour taste. Lemons are really sour, right? Lemons have a high content of acid. So acids taste sour. There are many metals that will dissolve in acids, but not all of them. So if we see something like zinc and we put this in hydrochloric acid, the zinc will dissolve in the acid. And we see that their formulas usually start with H. So these are two examples. The formula starts with H. Those are going to be named as acids when dissolved in water. So two types of acids. All the books talk about binary acids and oxyacids. I like the term oxyacid. Oxyacids have hydrogen and one of those oxyanions that we learned, phosphate, sulfite, something like that. So oxyacids contain oxygen. Binary acids are the other kind. Book describes it as containing only two elements. I can think of at least one that has three elements. So I don't particularly like that, but oxyacids and the other kind. So the other kind, the binary acids, this is how we name those. We use the prefix hydro, which is kind of standing for that first element, hydrogen. And then we take the base name of the nonmetal and we change its ending. Instead of "ide," like we've been doing, we change it to "ic." And then we add the word acid. So acids are going to have two names also. A first name, but the second name is always acid. So let's name this guy HF. Is this an oxyacid or the other kind? The other kind, right? There's no oxygen. So then the pattern is hydro, and we change fluorine to, I hear mumblings, fluoric, hydrofluoric acid. Now, I just want to remind you There is no flour in fluorine. See the flour? Fluorine is gluten-free. It's fluorine. Well, I can't write that. It's UO, not OU. So if you see flour showing up in any of your names, you've switched those letters. Okay? Hydrofluoric acid. Any questions? The oxyacids. So the names of the oxyacids are based on the name of the oxyanion. So we have to identify the oxyanion. And then what we're going to do is, if that ion name ends in 8, we're going to change 8 to ic and add the word acid. If it ends in ite, we're going to change it to us and add the word acid. So how do you remember that? A mnemonic is a good way. Oh my goodness. Okay. It's Monday. Rick ate him before he could bite us. Never really pondered who he is. Because this is a weird sentence, isn't it? So Rick ate him before he could bite us. How's that going to help us? Ite and us go together. Ate and ick. Okay, so that's the one I've always used. Don't remember where I learned it. Another one I've heard is the white mouse ate icky cheese. Okay, so there again we've got ate and ick. We have ite and us. Okay, those go together. Any questions? So how do we do this? So let's name this acid. So it starts with H. It's an acid. It's dissolved in water. It says aqueous. So we cover up the hydrogen and we look at what's left. Does that have oxygen in it? It does. So what we need is the name of that ion, NO2. What's the name of that? Nitrite. So this is NO2 nitrite. Can't make dots today. So what do we change ite to? Us. Bite us, white mouse. So this is going to be nitrous acid. We don't put hydro in front because that's for the acids that don't have oxygen. Just change nitrite to nitrous and put the word acid. Any questions? Here's the name of an acid. Write the formula. Well, is this an oxyacid or the other kind? So I've heard both. How do we tell? What does it start with? Does it start with hydro? No. If it starts with hydro, it's the other kind. Just two things. If it doesn't start with hydro, it's an oxyacid. So then we're going to take this perchloric, and what do we change ic to? 8. So this is an acid containing perchlorate ion. So perchloric comes from perchlorate. What's the formula for perchlorate? ClO4 with a -1. Because you memorize it. It's one more oxygen than chlorate. The rest of this is hydrogen ions. Remember, when we put this in water, it separates into ions. It makes hydrogen ions and some other ion. So the other ion here, besides the perchlorate, is going to be hydrogen. And the charge on this anion will be the number of hydrogen ions that you need. So the formula for this is HClO4. And to be strictly correct as an acid, we should say it's dissolved in water. Any questions? So I kind of did an example of this already. Writing formulas. When you look at the name, if it ends in acid, it's an acid. Could it get any simpler than that? Right? It tells you it's an acid. If it's an acid, it starts with H. The formula starts with H. So you figure out the formula as if it was ionic, even though it isn't. If it starts with hydro, then it's a binary or the other kind of acid. If there's no prefix at the beginning, no hydro, then it's an oxyacid. So for oxyacids, you look at the name. If the name is something like sulfuric, then you change ic to ate. That would be sulfate ion. If it ends in us, like nitrous acid, then you change that to ite. So it's the reverse of writing the names. Okay, so some extra examples. Hydrocyanic acid. Is this an oxyacid or the other kind? It's the other kind because it starts with hydro. Okay, so hydrocyanic acid. Well, there's going to be hydrogen ion and cyanide. So the pattern with the binary acids or the other kind is you would take something like nitrogen and change it to nitric, or not oxygen, chlorine and change it to chloric. So here it's got this ic ending, but cyanide is not an element, is it? It's an ion. It's an ion. Started to say something else. It's a polyatomic ion that you're supposed to memorize. That's cyanide. This is why I don't like the name binary acid, because this is technically a binary acid, but there's 3 elements. So you look at the charge on this and the charge on the hydrogen ion, and this is going to be HCN aqueous. Any questions? Let's just do another one here. How about hydrosulfuric acid? Is that a binary or an oxyacid? Binary. Okay. If it starts with hydro, no oxygen. If it doesn't start with hydro, it's got oxygen. So this starts with hydro, so there's no oxygen in it. So we've got a hydrogen ion, and then sulfuric comes from the element name sulfur. So here's sulfur. What's the charge on a sulfide ion? 2 minus. From its position on the periodic table. So then we look at the charges, and this must be H2S aqueous. Okay? How about this one, phosphoric acid? Is that an oxyacid or the other kind? Oxyacid, because it doesn't start with hydro. So phosphoric comes from which ending? 8. So this comes from phosphate. So we need the formula for phosphate, PO4, 3 minus. And it's an acid, so the cation is H+. The charge on this phosphate ion tells me how many hydrogens I need. I need 3 of them. So it's H3PO4 aqueous. If you forget the aqueous, I won't mark it wrong, but it should be there. Hypochlorous acid, oxyacid or other kind? Oxyacid. Hypo and hydro are similar, but they're different. This is hypo. So it's an oxyacid. Us changes to what? Ite. So this is from hypochlorite. So hypochlorite is ClO minus. Chlorate is O3. Chlorite is O2, hypochlorite is O. And then H plus, so put those together, we get HClO, aqueous. Any questions? It may look simple when I'm doing it, and once you see the patterns, it is simple, but it requires some practice before it gets really into your brain. So you need to do a lot of practice with writing formulas and names. So there are some pollutants, I'm not going to test you on this, but I think it's interesting, such as NO, NO2, SO2, SO3. So this is nitrogen monoxide, nitrogen dioxide, sulfur trioxide. These can form acids when mixed with water, such as rain. And so we can get different oxyacids forming from the pollutants in the air mixing with moisture, forming acid rain. Acid rain falls down, and it's not good for trees to be showered with acid, so it can kill them. Here's a picture of two very old statues, but this one has been sheltered from the rain, and this one has not. And you can see that the acid rain is just literally eating the stone away. So that is something that we should be concerned about, is these sorts of pollutants in the air. It's just not that they cause smog, I mean they do, but it's also that they cause acid rain, which has lots of negative consequences.